All right, just a quick explanation of what the oscillators are going to be like and what they will and won't be able to do. So there's going to be a couple things involved here. The oscillators are going to be these three knobs. Well, really just these two knobs. So that's oscillator 1. There's going to be one more oscillator. It's going to consist of these three knobs. And what you're going to be able to do is you have a selector switch here and a selector switch here with 6 options. This first selector switch will allow you to select the waveforms as well as noise if you'd like. The second one selects a shift in variable, or a shift in, frequency. So if you're in the middle, you'll be able to go up an octave, up 2 octaves, or the other way, down 1 octave or down 2 octaves. So that's oscillator 1, and then next to it is just a mixer. Oscillator 2 has the same options here. You have a waveform selector, and then you also have an octave jump, and then you have one more potentiometer here, and this will be a smooth frequency adjust within that octave. So if this jumps every 12 notes, this will allow you to smoothly jump positive or negative the frequency range of plus 12 or minus 12 notes. So, and then there's also some switches here, which I'll get to later. Before we get to the oscillators, we need to time this thing. And we've already covered timers on the MSP, so I'm just going to try and add that really quickly. The way we have this set is, if you remember, our submaster clock is clocked at 12 megahertz. And so if we divide by 250 here, then what we end up getting is a 48 megahertz clock pulse, which will be DVD quality audio and the standard computer audio. So now we can get to the oscillators. We're here in the main function. We're going to go into our infinite while loop, and it's going to be running. And like I said before, it's going to be waiting for trigger sound to become 1. When it becomes 1, we're going to reset it. And then we're going to jump into the sound path. Sound path is our general overall flowchart where we grab any MIDI changes coming in to the synthesizer. This just blinks a light if a key's pressed or not. And then here we're going to add our oscillators. So we're going to run our oscillators. And we'll just add this right above here. The first thing we want to do is a frequency calculation for what we should run at, or what each oscillator should run at. So define F1 to be the frequency for oscillator 1. And this is where the variables may not make sense right now, but I'll try and explain them, and they relate to the knobs that are going to physically be present. So first is, actually wait, let me put something after this first. So we have the current frequency. So this is the frequency that is currently being pressed on the synthesizer, and is going to be scaled. So the first scaling is called NN pit var 1. So this NN pit var 1 is going to be a mod wheel. So if you want to glide up or something, or do a vibrato, then that's what that's going to be. Plus this PM01 term, which is also going to be a sort of pitch modulation. Anything that begins with NN is going to be an analog input, so a potentiometer input of some sort. And then all this, because this NN pit var and PM01, those are going to be basically max value of LV max, which is a 8-bit, the maximum value in 8-bit. So since we're doing this multiplication and we're dealing with integers, we have to scale that. So, we're going to divide by LV max. All right, now the actual frequency that we're using. So we're going to grab this from the frequency list. And we have 12 times dn octvar 1. All right, so then we're going to do something very similar to the second oscillator. And this is very similar. You have the current frequency, then it's added by kind of a pitch mod, and then you have a octave modulation as well, or octave offset as well that's taking place. All right, now the next thing is, in order to jump through the waveform list, what we do is we jump our index with respect to time. If it's a higher frequency, we jump through the table by moving our index faster, so larger jumps between time steps. And as that grows, it'll grow out of bounds outside of the wavetable size. So every time it jumps outside of the wavetable size, we'll have to scale it back in and start it over in the wavetable at the correct point. So once you run out of the wave, you repeat the wave, and you have to do that rollback maneuver. So we can do that by specifying T1. So T1 is time of oscillator 1. It's just the index going through the table for oscillator 1. So we set that equal to T1 minus time lim, which is our scaling factor sort of limitation on time. And then we're going to do parentheses here, T1 divided by time lim. All right, now it's the actual oscillator. So OSC1 is the current level of the oscillator 1, essentially. So I'll pull that directly from the wavetable. The first index is dn os type 1. dn, so that's a selector switch where you get to select your waveform type, which is what the first index is. Second one is the progression through that wave. So T1 divided by sample rate. Now we also have to progress time through our table at the correct rate. So this is where the frequency comes into play. This is how we run through the table faster or slower, depending on if we have faster or slower frequencies. And same for time 2. All right, so that's actually our oscillators. That's all we have to do. Except we do need to specify these variables because I haven't specified them yet. We're going to separate also the we're going to separate here the input controlled variables. So these are everything that's going to change from our inputs. And I'm also going to throw in some mixer variables here because we're going to run a mixer. Before we run the oscillators, we're going to set the current frequency. This is going to be the frequency taken from the frequency list of the current note. The current note we dealt with earlier in get MIDI changes. So here it is, MIDI note value. So we'll go ahead and toss that in there. Yep, remember that time limit variable? I need it. Okay, so the Next thing we're going to build is the oscillator. I'm sorry, not the oscillator. We just did that. The mixer. So let's go up here and declare it mix oscillators. Go into the sound path. So after we run the oscillators, we're going to mix them with mix oscillators. We'll go ahead and throw this right here. All right, this will be really easy. Basically, we have our output of the mixer, so our mix sound. This is also going to have some knobs in the mixer, which actually, let me show you that. Pull this back out. So our mixer here. So these are the oscillator 1, oscillator 2. The mixer is this location right here, or these knobs right here. There's 4 of them. One for level of oscillator 1, one for the level of oscillator 2. This one, or this one, I haven't decided yet, which I guess I will in a bit, but one of these is an external input, and the other one will be a noise. And it'll just be it won't be a pink noise or anything, it'll just be plain white noise. So not only will we mix these in, we'll also have to generate the noise. First is to handle maybe oscillator 1. So we go back here. So we have NN LV1. So as you increase the knob level, you increase the sound amplitude. We're also going to add this by AM01. This is the analog modulator number 1. So there's, not modulator, modifier. There are a number of modifiers on there. So you can set a modifier to automatically adjust the volume of a mixer. And then we're going to multiply it by oscillator 1 value. All right, and then oscillator 2 is just going to have only the knob. It's not going to be affectable by the modifier. And then after this, we're going to put in the noise, which we can also control. So, and then LVN, that's the level for noise, times and the noise generated. And then one more, I said there's an external input, so let's add that as well. And then this NN external is because the external will have to be an analog input, just like a potentiometer, except we're going to pull it very, very fast and reconstruct the waveform going into the system. All right, and because we're doing integer multiplication, we also have to scale this thing. If you're doing a true mixer, you would just divide by 4 and go forth with that. But in this case, I'm actually going to scale it by how much I'm multiplying things by. And that way we always have a full height waveform and full resolution no matter what we do. The only issue with that is as you adjust the mixer while a sound is playing, it could sound a little, the amplitude could dip a little bit, but I don't think it'll be too much of an issue in this case. So 1, 2, noise. Then we have, whoops, the external. I'm also going to add this LV max here. This LV max takes care of the modifier scaling. So that's the basic mixer, the only next thing to do is to add noise. Now, you could add noise through creating a waveform table, just like we did the other things. But the only problem with that, the slowest rate you can go through that table dictates the slowest part or the lowest frequency content of the noise. So to get around that, what we need to do is generate a random noise. So we'll start with sort of an algorithm that feeds into itself and generates pseudo-random values. So we'll start with gseed. It's going to equal something really funky, 214.013. We'll multiply it by gseed. Then we're going to add 253.1011. And then the final noise value will be this. The gseed bit shifted 16 bits. And then we're also going to constrain it. So that's how you generate noise in a digital environment, pseudo noise anyways. Okay, level 1 is LV max. Level 2 is 0, which means you won't hear anything out of the second oscillator. We can adjust that later. But it appears everything is set up. So I believe there's only one more thing to do. We'll plug it up and look at waveforms. And if this doesn't work, we'll just go back. All right. So we got our synthesizer here. Connect up the outputs first. All right, the output of our DAC is there. Connect our keyboard up. Power it on. And also load the code onto it. All right, I'll hit run. And let's see what happens. And guess what's happening? Nothing. The output of the sound comes from our mixer. The sound that we want to output is called mixed. So we're going to go into our sound path. And after oscillators, we'll say the DAC output or a DAC out is equal to mixed. But we're going to left shift it by 4. Then we're also going to go into initialize GPIO and set up the DAC port. And now the output of those pins should be the DAC output. I just totally ignored this. There we go. Go by the signal offset. Now this should be left shifted by 2. I mean by 4. One more try. We're close. And there we go. Finally. All right, so there's the sine wave. As I press different keys on the keyboard, it lowers in frequency increases in frequency as I play different notes. Something that we can do is go up here to our variables and adjust those knobs without having the knobs. So we'll add an oscillator 2 here. Alright, so oscillator 1 and oscillator 2 are both at their maximum mixer volume. We could do sine wave for 1. Let's do a square and a triangle wave. So oscillator 1 will be a square wave, and oscillator 2 will be a triangle wave. We can do an octave variation as well. Oscillator 2, or pitch variation. Oscillator 2, we'll put in pitch variation 2. So we've got that. Let's just see how that sounds. Upload this with the new variables. Let's see. So yeah, let's listen to that funky thing. Alright, and we can play different notes. So that's what that sounds like, and we can fiddle around with it more. So let's change things to add in a saw wave here. We'll go back to our knob variables. And so we're doing a triangle and a saw. All right, and we'll increase the volume as well, almost to max value. Go ahead and, or the pitch, sorry. And we can see what that sounds like as well. Horrible. Alright, I got one more I'm going to show you. This one is going to be 2 sine waves, which are the most basic, but they have the least frequency content, and when they match exactly, you can get them to sound a little interesting. So we're going to vary the pitch of one of them very, very slightly. This is a very slow constructive, destructive interference thing going on. There we go. I'll let you hear that. Alright, so that's kind of what you can do with 2 oscillators, where one of them you can vary the pitch a little bit. But yeah, that's it. This is through an 8-bit DAC. It still looks pretty smooth. It'll turn out better when we add the reconstruction filter after it. Right now this is the raw output.